After modeling the first component, then it's time to, let me see, we're gonna model these profiles or the C channels. Watch this very well. Let's see. We got multiple approaches for modeling these profiles. However, we can use the family in generic model, but I prefer to model them in the category of structural, and I want to associate them to structure. Family category, connection, structural connection. Since we can schedule them in the schedule table like this way, and then I save it. Again, from File, New Family. Firstly, I want to open the metric profile, family template file. Then I want to draw the C channel. Firstly, drawing these reference planes by this way, and also this part, measuring the dimensions, and then I want to equalize them 1 to 5 at the dimensions 61 and 21. I associate this to W or width, and then I associate the other one to H or height. 17 and 43.8 based on the existing dimensions, or I can round it up 45. Watch this. Then let me check the family in the left view. Here, let me measure the total 47, so 45 is okay. Let's see, 17 for height, and I draw two references, 90 degrees for the angle, measuring the dimension 10. I need these two fixed, 5 and 5 for both sides. Then I start drawing from this part. Check it out. And then I define the offset, 8 millimeters, not 0.8. Then I hold down the cursor of the mouse, press down tab to select the boundaries, offset 0. I enclose them. Well done. Then for section shape, I can choose C profile with ellipse. Profile usage to generic. Then I save the file as in the, let me specify the file path where we are saving the files in ceilings and files or ceiling files. IR dash C channel profile. Then from file, new family. And we haven't talked about the structural framings yet. However, we don't want to get through them, but we want to use them in the ceilings. So metric structural framing beams and braces. Note that we can use the families of line-based, generic model, or model floor, but I prefer to use metric structural framing since it is helpful to in actually schedule tables. Here we load into the family of structural framing, saving it IR dash C channel beams. Well done. Here we want to draw an extrusion and then sweep. I mean the previous one was extrusion, but here we need a sweep. We sketch the path, we align the path like by this way. Afterwards, in the left view, finish, reload the profile like this way and finish. Watch it into the view. Then I selected associating the material, selecting the default one. Then for angle, we can create a new parameter to be able to rotate it whenever it was needed. Cross section rotation, for instance. Instance and okay. And profile is Philippe, we don't need it. And for the subcategory, open the drop down list and then we can specify it. For manage tab, objective styles, let me create a new subcategory as ceiling C channels. Okay, black color, the line weights are okay. Then we can define a material for it by default like galvanized steel. I added. I can define a new name for it, ceiling channel, ceiling C channels actually. Well done. I check the appearance. Okay, I close them. And then in this part, the material for model behavior is steel. And then in the other part, we select the profile, see profile with lips. We don't change the other sections. So, and steel, all we export as geometry, it is used for IFC. We got nothing to do with it. In the following, these are okay. And save. I save the file. And then I set the subcategory to ceiling C channel, which the material. And right now, since we have defined a material for the subcategory, the steel material has been specified for this, and you can see structural material by category. I save the file again. And then I open the project. Wait for a second, please. Right here. For instance, for the ceilings, I open ceiling 1. Note that the ceiling plan, as I mentioned, is reversed or is opposite to floor plans. So here we are looking at the model from bottom to top, but I need to look at it from top to bottom. Here I can draw a section detail view to check the details, and this is a technique here. Watch this. I open the detail view. Watch this. We got them from top. So then I can load this profile as a structural framing into the other project, and I can use this as a beam. And since we are in the section view and we don't have any work plane, we can pick a plane. For example, I click on the face and consider it as a work plane, then I start drawing. In the CAD file, as you can see, at the corners we got some other profiles, some L-shaped profiles, and the profiles, the C-channel profiles at the center. I draw this for now. I select it and 500. I don't change it. I open the 3D view like this way. Watch this. This is the result. I have selected the wrong face. Let me select it, and then I want to move it upwards with defining a value for z offset value, or setting this z justification to bottom, so it is justified from the bottom face right now. Anyway, we open the plan view. We can use array, move to second, then 500s, like this way. Afterwards, for the number 8 or 10, like this way. Check it out. And then I can select the group of profiles, ungroup them, then multi by this way. This type of modeling is long lasting, time consuming, since high accuracy is needed. So we can use this structural framing as a great option. And as I mentioned in the LOD or level of detail 400s, it's really time consuming and very costly, and you have to think about all of the aspects before signing the contract. From the structure tab, I select beam. Watch this. See channels that are considered as beams, bottom for the justification. Then for the offset value, 17 millimeters. Since they are going to be placed on this, I draw this one. Check it out. 500 for the distance. Look, they are placed on the another group. And again, to make sure, I adjust the section box to check their positions. Watch this, they are exactly on the other group. Here in the detail, array, 500s, 8 or 12 or 11, better. Then I select them again, I select the elements, I ungroup them, trim, like this way. I open the 3D view, watch the result. Great. We model the substrate, and here, as you can see, we have to place these connections at each intersection. I can get back to this family, or I can close this part. Then in this part, I want to load it into this project. Let me open the detail view. Then I add it at the intersections. Here in the 3D view, let's see and check the position. I click and drag, filter, structural connections. Okay, let me find it. Watch this. It is placed on the level. I adjust the offset from host, 3200s. Watch this. 3400s, better. And I use space to flip it. I press down a space. After changing the direction or rotating it, 300s and 3300s, 3375. Watch this. Then I align it, the face 50 bottom face of the connection, like this way. Then I open the detail view to adjust it better. I align it with the central of the profile. Watch this. It is placed exactly at the position we need it. And then in this part, I want to put it into a section box, or Control Z. I duplicate the 3D view, and then I put this component into the section box. Look. Then if I adjust this component, we can control the rest of them. I open the 3D view, left. I should move it upwards, as you can see. 5, 8. Watch this. Better. Look at this. Right now, both profiles are connected to each other. Or I can minimize the height of the connection to connect it to the um, profile actually. Anyway, let me open the detail view. And as you are concerned, the sizes and the dimensions of the connection are fixed, so if we add one of them, we can use array and then add the rest of them, 8 for example, like this file. I meant 10. Again, I select these, ungroup, again from the center up to this point, 12, 10 actually. Again, I select them all. Now we ungroup them to simplify the process. Model group, ungroup them again. Then I select these up to this point, copy. Then from the axis to the another axis, opening the 3D view. Watch this, perfect. And right now we have modeled the substrate, the profiles, the connections. Then here we can brush aside the thickness of the panel, and I can delete the thickness here. And we only consider the thickness for the ceiling when we don't want to display the substrate. So we delete the thickness, watch this. And since the connections were hosted by the ceiling, we have to adjust their heights again, 3250. And here they are.